Okay, so now what we're going to do on notes 2 is we're going to solve equations with variables not just on one side, but on both sides. So what you need to understand up here is it says when more than one variable term or constant is on the same side of an equation, we can combine like terms, then continue solving. So what we're doing here is we are combining the 4x plus the 3x, and that gives us 7x. And then you can go ahead and finish working that out. Now, what we have seen in the past years is that once we get to this point, you see the incorrect sign right here? People want to try to subtract the variable terms from each other that are on the same side. You don't do that. If you're going to get rid of something, you're going to get rid of it on one side of the equation and then also on the other, not on the same side. So this is incorrect. Do not do it that way. All right. On letter B, here you see we have a 6 and a minus 7. So those are like terms. They're on the same side. So 6 minus 7 is a minus 1. All right, when we look down here at this one, here we've seen this in the past where some students want to subtract 6 from the same side. No, do not do that. You combine the like terms if they're on the same side. Okay? All right, so let's go ahead and take a look at number 1. So what we're going to do is we're going to identify, you have a variable term and a constant on the left, and you have a variable term and a constant on the right. So remember what I was talking about when I was talking about the Vikings and the Cowboys and how that equal sign is a line of scrimmage? Well, the Vikings have to all be on one side and the Cowboys all have to be on the other. Now, what I like to do is I like to move, once I'm balanced, you have the same number of variable terms and constants on one side as you do on the other. So what I like to do is get the variables on the left. So I'm going to subtract 2x from both sides. Whatever you do to one side, you do to the other. So this is x plus 8 equals 13. And now it's just a two-step equation. You're going to subtract 8 from both sides. So x is equal to 13 minus 8 is 5. And then you can plug 5 in place of each x and see if the left side is equal to the right side. All right, let's take a look at number 2. Here's a variable term, here's a constant, here's the equal sign that divides the equation in two. Here's a constant, and here's a variable term. So what I'm going to do is I'm going to add 2a to both sides because I'm going to bring my variable term and bring it over here to the left side. So negative 7 plus 2 is negative 5. A minus 10 equals 20. And then you just go ahead and carry on through. You're going to add 10 to both sides. So we're going to run out of room. Negative 5a equals 30. Divide by negative 5. And a is equal to negative 6. All right, let me move this up here. Okay, let's take a look at problem 3. Here we have a variable term on both sides right there. So you combine it. Okay, so 4x and 2x is 6x plus 2 equals 3x minus 22. Okay, and then you are balanced. You've got a variable term, a constant there, a variable term, and a constant right there. So you're balanced. So I'm going to move minus 3x, move my x terms to the left. So I have 3x plus 2 equals negative 22. And then it's just a two-step equation. I'm going to subtract 2 from both sides. So I have 3x equals negative 24. And then divide both sides by 3. So x is negative 8. All right, let's take a look at problem 4. We have a fraction. But this one's an easy fraction because it's half. And what's inside the parentheses? Those are even numbers. So half of 2 is 1 minus half of 4 is 2 minus 2x equals 13. Okay, so we have variable terms on the same side, so combine. So we have 1 minus 4x equals 13. Then we're going to subtract 1 from both sides. Bring down your negative 4x equals 13 minus 1 is 12. Divide both sides by negative 4. And x equals negative 3. All right, now what we're going to have are these specials. That just means that if variables drop out and you have the same thing on the left side as you do on the right side, or if the left side is equal to the right side. Let's say that I subtracted x from both sides. That means both of those will cancel out, and 4 is equal to 4. Or let's say that I subtracted 4 from both sides. So when I do that, then I'm left with x is equal to x. Or then if I subtract x from both sides again, then I have 0 is equal to 0. So all in all, if the left side is equal to the right side, then that means any number you put in place of x would make that statement true. So this is what we call, if it's true, it's going to be all real numbers will work. So you can either say ARN for all real numbers, or you can use that R. All right. So then let's take a look here, over here on this side. The variables or constants drop out again. But let's say the left side is not the same thing as the right side. So if I were to subtract x from both sides, that cancels out, and I'm left with 4 equals 3. Is 4 equal to 3? No, it's not. So therefore it's false. That means you cannot substitute any number, fraction, decimal, negative, positive in place of the x on the left or the right to make the left side of the equation be equal to the right side of the equation. So therefore there is no solution. So you could go ahead and write NS or do the circle with the line through it. So let's go ahead and practice some of these. So let's take a look here. So we have 3x plus 8 equals, okay, distributor of 1/2. So half of 6 is 3. And half of negative 2 is negative 1. Okay, so I've got variables on both sides and constants on both sides. So the first thing I'm going to do is subtract 3x from both sides. They cancel out. So I'm left with 8 on the left and negative 1 on the right. Is 8 equal to negative 1? No. Therefore, there is no solution, or you can just do a circle with a line through it, whichever one. All right, let's take a look at number 6. Okay, so here, you see this equal sign? Well, you have a 1x here and a minus 4x there. Those are like terms you must combine. So 1 minus 4 is negative 3. X plus 6 equals, and then we're going to distribute. Negative 3 times x is negative 3x. And negative 3 times a negative 2 is a positive 6. So we're balanced. And if you notice, there's the very same thing on the left side as there is on the right side. So no matter if I decide to add 3x to both sides, you see how you have 6 is equal to 6, which is true. So it'd be all real numbers. Or if I decide to, if I decide to subtract 6 from both sides, then I have negative 3x is equal to negative 3x. Either way, the left side is equal to the right side. So therefore, this is true. So it'd be all real numbers. Or you could do the do like that. I'm not real good at that, but anyways, that's what that would look like. All right, so I hope you kind of understand when you have variables on both sides, you have to get the variables on one side and constants on the other.